This is section 3.1 on quadratic functions. And the first thing we see here is the general form for a quadratic, ax squared plus bx plus c. And most of us know that that's a parabola. And a lot of times you'll just do your hand like this because you know the shape of it. It is a U shape. Could be right side up, could be upside down as well. So those are the shapes. So here we have that kind of in a concept box. If a, that's that number in front of the x squared, if that's greater than 0, meaning positive, so if it's positive, it's going to go up, it's opening upward, and so that's that picture. If it's less than 0, if it's negative, it's going to be coming this way. And here's that one. This is this equation here, 4 minus x squared. So there's a minus in front of the x squared, whereas here it was 2x squared minus 4x minus 1. So the highest point on a parabola or the lowest point is called the vertex. The vertical line that goes right down the middle right there is called the axis of symmetry. So those are some terms that we're going to be seeing. Let's move on down here. All right, we talked about that a value, the leading coefficient, determines whether it opens up or down. It also controls the width of the parabola. Let's look at here. And this green one is y equals 2x squared. The blue one is a basic y equals x squared. So the smaller the absolute value of a makes the graph wider. So here's this red one is 1/2 x squared. So the smaller the number, the wider the graph gets. The bigger the number, like if you had 8x squared, you'd go even more like that. And so here they are upside down. So here's a negative 1/3. Here's the basic negative x squared. Here's negative 3x squared. So the bigger the number, the more narrow the graph gets. The smaller the number, the graph gets wider. All right, here's another form, and it's sometimes called the standard form, but this book likes to call it actually just the vertex form. It's wonderful if it is in that form because you can just pull out the vertex. You can see what it is right away. In this form, a parentheses x minus h squared. So if it is in this form, the vertex is literally h comma k. That would be the coordinates of it. So sometimes it's really nice to be able to convert from the general form, which was the ax squared plus bx plus c, which is this form, to the vertex form. So let's see how that happens. All right, so we're going to follow the steps that I have written on the right. And so if it's given to you in f of x form, you want to change the f of x to y. So I'm going to do that here. Next step says move the constant. This is the constant, doesn't have an x with it. So if I'm going to move it, it's being subtracted. I'm going to add it to both sides. So I have y plus 3 equals x squared plus 6x. Okay? Now, I'm going to, on each side, put a box. You have to do the same thing to each side of an equation if you do anything. And what I'm going to try to do is create this thing to be a perfect square trinomial. A perfect square trinomial. And to do that, you're going to take half of this term here. So half of 6 is 3, and then you square 3, you get 9. 9 will then be the number that goes in both these boxes. So I haven't really changed anything if I add the same thing to both sides. So you're going to, this is now a perfect square trinomial, and you're going to factor it, meaning you're going to rewrite it as something squared. On this side, you're going to just combine. So you have y plus 12. Now, what goes here is x, you match that sign, and whatever half of that was, that's the number that goes here. So if I square x plus 3, I end up getting that because I created a perfect square. All right. Last step is to subtract the constant back to the other side. So I have y equals x plus 3 squared minus 12. So I have now put it in that vertex form. So what is my vertex here? My vertex is h, and it was x minus h here. So you always change the sign of this one, comma, negative 12. Okay, so if you can get it in that form, you just pull out those two numbers, always changing the sign of this one that's in parentheses. The other way you can do that is to use the vertex formula. The vertex formula is nice if it's in this and you don't want to change it to the other form. You just determine what your A, B, and C are. Remember, this is A, the number there, this is B, this is C. So A in our case is 1. B is 6, C is negative 3. So if I use my formula, negative B over 2A, negative B would be negative 6 over 2 times 1. And that would be negative 3. Okay, and so then that's the x part of our vertex. If we're going to find the y part, we're going to plug in. It's f of that. So we find f of negative 3. That means we plug it in. Negative 3 squared plus 6 times negative 3 minus 3. And if we do that calculation, we come up with negative 12. So our vertex is negative 3, negative 12. And I believe that I made sure we did the same one. So here we started out with that and we converted it to this form and got that vertex. Here we used the vertex formula and we did that. Now the other way that you could do this would be to use your calculator. I'm going to have my calculator come up so that we can do this one on there and make sure that you are aware of that as well. Okay, so, whoops, didn't want that. Okay, so I'm going to bring this over here and let's put in this right here. All right, so we're going to go to y equals. We're going to clear out anything that you had in there if you wanted to follow. All right, we're going to put x squared plus 6x minus 3. I don't know what the window is, so I'll do a zoom 6. That just puts it back to normal. If you'll notice, I cannot see the vertex, so I do need to be able to see it to work with it. So what do I need to change? My y min. So I go to window, and I'll go down to the y min, and I'll make it negative 20. I don't know if that'll do it, but let's try. Perfect. All right, so to find the vertex, it is a minimum point. Second calc, min, number 3. And remember that you always do left and then right. So I've got to use my left arrow and get this cursor over to the left, hit enter, over to the right of that lowest point, hit enter, and enter a third time. Now negative 2.99999 is essentially negative 3. We would use the negative 3 and the negative 12, and we did get the same vertex. So that's 3 ways to arrive at the vertex in a quadratic equation. Changing the form and just pulling it out, using the formula, or using your calculator. All right, let's look at some problems and see how we can do on those. All right, number 1 says identify the vertex, and it's already in the vertex form. So remember, we're looking at these numbers here, and so we're going to pull that out. And what do we have? The vertex, we change the sign of this one, 7, 4. And it says type an ordered pair, so be sure you put it in parentheses, and that's what's going in that box there. Number 2, identify the vertex and the leading coefficient, and then write it in the other form. All right, so the first thing you want to do, this isn't quite in the right form, we have this 1 in the front, is to reorder it. So we have -2 parentheses x minus 2 squared plus 1, because that's a positive 1. All right, so now I can pull out the vertex. Remember that it's here and here. Remember that I changed the sign of this one. So I've got 2, 1. That's my vertex. The leading coefficient is this number right here. So that'll be a -2. Write the expression as ax squared plus bx plus c. So that means I need to kind of expand this. So I'm going to have -2 times. Now if I square this, that's x minus 2 times x minus 2. That's x squared minus 4x plus 4, and then I have a plus 1. Okay, get rid of that. All right, so now I have -2x squared plus 8x minus 8 plus 1. -2x, I'm going to put this in red. Final answer, -2x squared plus 8x minus 7. And that would be for that box. Okay. All right. Number 3. We are in the standard form and general form. Sorry. We're in the general form. We want to write it in the vertex form. So this is where we're going to kind of complete that square. That's what that was called. So we have x squared plus 4x, well, let's write y. Y equals x squared plus 4x minus 7. We're going to add the 7 to the other side. I'm going to go ahead and put my box. All right, what goes in the box? Remember, we take 1/2 of 4. 1/2 of that number is 2, and 2 squared is 4. So 4 is going here, 4 is going here. I'm going to factor that into something squared, and I'm going to combine those two. All right, this is x plus, match that sign, and then whatever the half was, that's a 2. All right, and then I'm going to move that over. All right, so that equation there goes in this box here. Now, the f of x is already there. That's the same as your y. So in your box will go x plus 2 squared minus 11. And then when we pull the vertex out, we change this sign, -2, -11, ordered pair. All right. Use the vertex formula to do this one, and we've got the same thing. Now you could, it says use the vertex formula, so we're going to do that one on this one. We're going to say A equals B equals C equals. So my A is 2, B is -12, C is 16. So H, because remember our vertex is H comma K. So H is -b over 2a, and that is equal to -12 over 2 times 2. So that's 12 over 4, which is 3. All right, so that's going to be our x part of our ordered pair. And then f of 3 equals 2 times 3 squared minus 12 times 3 plus 16. So that's 2 times 9, that's 18 minus 36 plus 16, and that's 18 and 16 is 34 minus 36, this will be a -2. So the vertex is 3, negative 2, right there. All right. The function is increasing 4. All right, so let's think about this. Where is 3, negative 2? 1, 2, 3, down 2. There's our vertex. And it's going to go up. So we got something like that. So it's increasing, and we're over here at x equals 3, because that's that value right there. So it's increasing here. It's decreasing here. So it's increasing for x is what? Greater than 3 or less than? What is it? It's greater than 3 because it's everything to this side. And it's decreasing for everything to the left of 3. So that would be less than 3. Okay? All right. Number 5. A carpenter is building a room with a fixed perimeter of 232 feet. What dimensions would yield the maximum area? All right, and you may be wondering, what does a rectangle have to do with quadratic? But this is where we're going to model what we've got, and quadratics will come in handy. So the first thing that I would do would be to draw a picture. And we don't know anything really, except that we have 232 feet to use to go around this room. All right, but we're saying we could do this, we could divide that 232 a lot of different ways. What way is going to give us the biggest area inside? So just to think about that, if you had a plain old square and all you had was 10 to use, think about, okay, I could put 2 and 2, and 10 minus 4 is 6. I would divide that, and so I'd have 3 and 3. So those all add up to 10, right? Okay. And then what if I did it a little bit differently and I had 4 and 4? The 10 minus 8 is 2, so that splits into 1 and 1. So I can divide this 10 up a lot of different ways. What's the area in this one? The area is 6. What's the area in this one? 4. So depending on how I divide this up, I get different areas. So the question is asking me, what dimensions are going to give me the biggest area? All right, so all I know is that I've got 2 of these W's here, right? So if I started with 232 and I subtract 2W, that leaves me what's left to split here, right? And we divided that by 2. So now that's equal to one of my lengths. I think I can clean that up a little bit. If I divide 2 in there and 2 in there, what do I have? I have 1/16 minus W equals L. All right, so now let's change that. We have W, W, and we have 1/16 minus W and 1/16 minus W. Now that works because my W's all cancel out and I have 1/16 and 1/16. That gives me my 232. That's perfect. All right, but we're trying to maximize area. Well, what's the formula for area? Area equals length times width. So in ours, we've got 1/16 minus W, that's my length, times W. Let's distribute that and get 1/16 W minus W squared. All right, so we're saying that the area could be modeled with this equation. Think about that. That's a parabola, and it's an upside down parabola. Here we go. This is what this looks like. And around, across the x-axis, this is our width down here. This parabola is the area. So for some width, I get this area. For another width, I get this area. For some width, I get this biggest area. And that's what I'm looking at. So what am I trying to find? I'm trying to find the vertex. The vertex. You could try this in your calculator and you could put this in as your equation in y1. You would have to work on the window to get it because it would have to be a much bigger window than you'll see. So for this particular one, I think the vertex formula is really nice. to do that. All right, you would need to think of this as reorder this. Negative w squared plus 1/16w. So now I have a is negative 1, b is 1/16. So the h part of my vertex is, let me get a little bit more room here, negative 1/16 over 2 times negative 1, and that gives me 58. And then I need the area, which is the y part, so f of 58 is equal to negative 58 squared plus 1/16 times 58, and if I do that all out, I'm going to get 3364. All right, if 58 is my width, then 1/16 minus 58 would give me my length, which is also 58. So I've got all my answers here. I've got 58 for the length, 58 for the width, and 3364 for the area. And some people think, well, 58 and 58, that's a square, and we were asked for rectangular, but a square is just a specific kind of rectangle. So it does work. All right. All right, last question. If a football is kicked straight up with an initial velocity of 96 feet per second from a height of 6 feet, then its height above the ground, above the earth, is a function of time given by. So they've given you this equation. H of t is equal to. So that means height of the ball is dependent on the time. If you think about it, all right, if you kick a ball up in the air, it's going to make this kind of arc. All right, and across this way is not width in this case, it is time. And this is the height. So at one time, the height is here. Another time, it's here. At some point, it is at its highest part. So this is asking for what's the maximum height reached for the ball, by the ball. We could put this in our calculator and find it that way. And I'll do that here, but you could also do the vertex formula. It is totally up to you. If you have the tool, you should use it if you want to. Negative 16x squared plus 96x plus 6. All right, I'm going to hit graph. And we had done, well, I need to do a zoom 6 and get back to standard. Okay, so I'm going to need to change that window. Let's make the Y max, let's make that about 200. I think that's what I'm going to need. Let's see. Okay, so that works. And this may be one that the vertex formula would be easier too, but I'm going to go ahead and finish this. Whoa, made it go away. Second calc max Alright, so I'm going to bring that up a little bit and hit enter, and then go over to the right of that highest point. Enter and enter. Alright, so what we see is the max is at 3 up here to 150. So the y value is what we're asked to find. So 150 using our calculator. If we did use A in this is negative 16, B is 96. So negative B over 2A is negative 96 over 2 times negative 16. And that's going to give us 3. And then h of 3 would be negative 16 times 3 squared plus 96 times 3 plus 6 equals, and if you figure that out, you would get 150. So either way, either doing it with the vertex formula or the calculator, should get you that. So I think that will help you get going on section 3.1.